So I've got to be honest, in this question, I couldn't see a general way of getting this straight away, but I could see that the answers were independent of x. So I decided to put x in the simplest place that I could, exactly where t is, on one of the corners. Immediately, I get xt is 0, so xt squared is 0. And then x to q is just going to be the diameter, 10. So x q squared is going to be 100. Then I've got x to s. Well, because the circle has radius 5 and a hexagon can be split into 6 equilateral triangles, then the length of the sides of the hexagon are also 5, which means when I square it and get xs, I'm going to get 25. And the same is true for xu. This just leaves x to r and x to p, which will be exactly the same. So let me just draw that in. Actually, I'm going to draw it in green. Okay, this is the most complicated one, but what we create is a triangle. Um, and I just realized now I could have used trigonometry like just SOHCAHTOA. I used the cosine rule. I'll go for it in both ways. So if I've got 120 degrees in a regular hexagon, so if I split it into two, then this angle here would be 60. So I could say that this length here is going to be 5 sine 60. And then if I want the double the length, I'm just going to times it by 2. That gives me 10 times root 3 over 2, 5 root 3. So that is x to r, which means x to r squared is going to be 25 times 3, which is 75. And then x to p will be exactly the same. It will also be 75. So we add them up, we get 150 from the greens, we get 50 from the reds, that's 200 plus 100 gives 300. Let's just say we didn't spot to split it into two, which is what I didn't do. It's not too bad actually. So if I want TR squared, then I can use the cosine rule. It's going to be 5 squared plus 5 squared minus 2 times 5 times 5 times cos 120. That is going to be 25 plus 25, which is 50, minus 50 times cos 120. Just need to think through that one. So cos 120 will be the same as minus cos 60. And that is a half. So I'm going to get minus a half here. 50 plus 25 gives us 75, as we had before. Now, I hope you're not going to settle for that. That did work, but it's not really, as soon as we didn't have multiple choice, we couldn't, or we were asked to show full written solutions, that would not be a very good solution because it just shows that it's true for one position. So let's now work with a more general position. I'll put x here. Okay, but this argument is going to work wherever x is, as long as we justify it along the way. Now, what we can do is consider two opposite corners at a time. And then if we connect x up to q and to t, we'll see that we create a little triangle, and it will necessarily be a right angle triangle using the idea of angle in a semicircle. And then I know that xq squared plus xt squared is necessarily going to equal qt squared, because that's just Pythagoras' theorem, and qt squared is 100. So I've immediately found for a general x that xt plus xq is 100. But if I go ahead and draw my diameter using a different two corners, I get exactly the same thing. Now I'm going to have xr squared plus xu squared is 100, because again, we're necessarily going to go for the center. This is the diameter. And you can see where I'm going with this. I just need to use the final two, S to P. And once again, I've created a right angle triangle. xp squared plus xs squared is again going to be ps squared, which is the diameter, 10 squared, or 100. And if you add up all of these, you're clearly, again, going to get 300. And it doesn't matter where you move x, you're always going to create this right angle triangle. That's the beauty behind the angle and a semicircle circle theorem. So we know for absolute certainty that is going to be the answer, regardless of where x is. And you don't need to consider it around here. Due to the symmetry, you only need to sort of think, okay, as it's moving around here, what's going to happen? And hopefully I've convinced you that that is always going to happen. That you're always going to get these three different angles in a semicircle. Great solution to that question, a general solution as opposed to the way that I did it, which did also work, to be fair. Well done.